In today's lesson, I will show you how to propose a mechanism for a chemical reaction when provided the rate equation. So this method is useful for a two-step mechanism, although of course mechanisms can have more than two steps. So before we look at the reaction here, which is chlorine dioxide with fluorine, just going to summarize something very important concerning the rate equation and the rate determinant step. And the rule is this: the order with respect to each reactant in the rate equation. So for this one, we can see that chlorine dioxide is order 1, and so is fluorine order 1, because there's no indice saying 2 or 3 or anything else. It's just order 1. So the order with respect to each reactant in the rate equation is equal to the number of that reactant in the rate determining step. The rate determining step is the slowest step in a reaction mechanism and determines the overall speed of the reaction. So logically then, if you've got molecules in the rate equation, they are therefore going to affect the rate of reaction, which is why they must appear in the rate determining step. So this really is very important to follow because it helps you determine the rate determining step before you try and work out other steps in the mechanism. So the order with respect to each reactant in the rate equation is equal to the number of that reactant in the rate determining step. So imagine, right, I had an equation where it was 2A plus 3B goes to C plus D, where A and B are reactants and C and D are products. And then through experimental observation and taking results of rate against change in concentration, we determined that the rate law for this particular reaction was rate equals K, say A to the 1, B to the 2. So order 2 with respect to reactant B and order 1 with respect to reactant A. Immediately from that information, we can propose the rate determinant step, which might not necessarily be the first step in the reaction mechanism, but for the purposes of this, we just say first step. So I can see that it's order 1 with respect to A and order 2 with respect to B. So according to this rule that I've just put there, the order with respect to each reactant in the rate equation is the number of that reactant in the rate determinant step. So therefore, I can immediately say that one lot of A reacts with 2 lots of B to produce something. So that question mark will be an intermediate, a transition state, or some fleeting molecule that is formed during the reaction. That leaves me then step 2 to work out, which can be determined by what is left over from the overall equation. So the overall equation is this one here. That's the stoichiometric equation, by the way. And I can see that left over, I have one molecule of A, because there was 2A to begin with. I have one molecule of B. So remember, 3 lots of B, 2 of it has been used here, so we have 1 left over. So A and B is left over, and then they must react with this question mark, this intermediate, to produce the products C and D. So as you can see there, what I've come up with is, if I just use a different color for that, that is a simple 2-step mechanism for this reaction that I've just made up. To have the rate determinant step followed by whatever's left over being used in the second step. So that's exactly what I'm going to do here with this reaction involving chlorine dioxide. So let's take a look. So it says the mechanism for this reaction has 2 steps. Suggest equations for the 2-step mechanism stating which of these is the RDS, the rate determinant step. So I'm going to do exactly what I just showed you. Now, for step 1, we'll do ClO2 plus F2. We'll just take this as the rate determinant step. They're going to react together to produce something. Let's leave that blank for the moment. And then in the second step, you can see what I've got left over is another ClO2 plus it has to react with that intermediate, that blank, to produce our products 2ClO2F. So what I've got to do now is I've got to work out what that intermediate could be. Often intermediates will look quite strange compared to regular molecules. They may have a charge, they may be a radical, and that's okay as long as you put something sensible and the atoms balance to what is on the left-hand side of your step, you're fine. Anything goes really, because in order to identify it properly, you'd have to be given more information. So maybe in this first one, the ClO2 reacts with the F2 and it just forms a molecule where they're stuck together as just one thing. So it could be just ClO2 F2, whatever that looks like. Okay, so that would be the intermediate. And then that intermediate is what reacts in the second step, ClO2 F2, to produce the product. So just to do a quick atom check, we can see there's one chlorine there, and there's one there, two oxygens there, two oxygens on the right, and two fluorines. And then on the bottom, we have two chlorines, two oxygens there and there, so that's 4. So 2 times 2 is 4 there. And finally, two fluorines there, and there's 2 there. So it's completely atom balanced. That could be a possible two-step mechanism. Now, the rate determinant step is going to be the one involving the reactants in the rate equation, which I decided was the first one, so therefore that's the RDS. So this intermediate, what could that look like? You'd have to, like I said, you'd have to be given more information. So it could possibly be something like where chlorine is double bonded to each oxygen, like so, with fluorine like that. So maybe something along those lines. We don't know, but as long as you if you're asked to propose a structure, as long as you come up with some sort of structure, whether that's a charged species, whether that's something neutral like this, it will be accepted because you'd have to be given more information. So hope that was helpful. Check out the next video on rates where I walk through a full A-level past paper question. The link for that video is in the description below.